Hi guys, thanks for joining us today. So today we're going to be using a table mounted rotator to weld these cable glands up. Cable glands are 1.5mm, 100mm diameter, and we'll be using 0.8 wire, just standard carbofill. The machine we're using today is an ESAB Warrior 400 amp, and the welding mask is a 3M speed glass 9100 XX. So what we've done today is, because we're only welding 1.5mm and the specs on this actual unit are quite tight, so we needed to bring the weld size down. Normally we weld at 1mm or above, but we've brought it down to 0.8 just so we can do a tidier, smaller weld, if you like, keep within specs. So the method we're using for these brackets today will be a non-weave. It'll just be a straight weld. There's going to be no issues with penetration. I mean, it's 1.5mm thickness on either side, so penetration's going to be there while the settings are there. And you know, we're only welding about 18 volts at this point because that's all we need. We've turned the wire speed up a bit. If you can tell, it's running quite speedy as the wire. We do that to reduce the spatter, reduce the size of the spatter and stop it sticking. If the slower the wire speed, the bigger the spatter will get. We may get less spatter, but the bigger the actual balls of spatter will be, and they tend to stick a lot easier to whatever we're welding. So if we turn the wire speed up, we can use a little bit more power and we can keep the size of that spatter down so the spatter doesn't stick to the finished product, which works out. So as you can see, we've just set a chair on the bench there just to make it comfortable so we can get into a comfortable position for us weld, because it's quite a slow weld. Neat and tidy, one weld, no bumps, jumps, tacks in the way, so we just use the nuts there to secure it and stop it lifting while we're welding up, putting a seam round. Magnets would have been a good idea for this, but as it happens, I couldn't find any while I was jigging up. I couldn't find any for this job, but magnets would have been a quicker option. If I could have got magnets into jig, it'd have just been a clip on, clip off. Quick solution, which there's a few hundred of these to do, so it would have been a better solution, but they were unavailable at the time. The brackets we're welding are actually cable glands, so there'll be a 100mm or thereabouts cable going through these, which is some size of cable. And we make these quite often. So with this being an open corner weld, we've decided on a no weave pattern, because if we did weave the weld, it would just turn out bigger and you would get overlap both on the bottom of the gland and on the inside of the gland. With just running a straight weld, we can turn the power up slightly, get the penetration we need, and keep a nice, neat, tidy weld so that we don't have to do any cleaning or dressing later on. If we were using a thicker material, obviously we would be more likely to be weaving, but on this thin material it's so easy to get the right penetration, there's not much chance of it not bleeding through, so we get to do a straight pattern and we'll still be where we need to be. The ESAB 400 is a multi-process welder, so it will actually do MIG, TIG and MMA or stick welding. So it's a good all-round welder. It'll do gouging. It's a very good welder. Obviously, it's not being put through its paces on this job because it's welding 1.5, but it is a 400 amp welder, 3-phase, so it will tackle just about any job we can bring into the factory, really. So as you can see, once we're bolted up, the rotator's set to a certain speed. That speed's obviously been calculated on what we're actually welding, and that's the right speed for the settings. Normally, obviously, you control this manually, but it's taken out of your hands with a rotator. There is slight room for deviation if you need to speed it up or slow it down, but once the speed's set, really you need to be running at that speed. So if you dial that speed in just where you want it, literally, and your settings are all right, you've just got to point and shoot, and that's where you want to be. You want to be able to put every bracket in there, point and shoot. So long as you're firing that wire where you need it, you're going to get a perfect weld every time. So guys, thanks for watching. I hope this has given you some insight into rotators and how they can be used, and hopefully there'll be more videos to follow. Have a good day.